Here we have the function for dividing by x squared plus 10, and this is what the graph looks like. And it's a little bit difficult to see here, but the graph from the left side up to about look like it's about 1.8, 1.9, negative 1.8. We say that this part is concaving up, and then from negative 1.8 to about 1.8, the graph is concaving downward, and then from 1.8 to the right side, the graph is concaving up. So by looking at graph, we see the graph concaves up on the interval from the left side, which is negative infinity, to what it looks like about negative 1.8 or 1.9. The graph concaves upward and downward. Downward on the interval. It looks like from negative 1.8 to 1.8. And then graph also concaves upward from the interval, on the interval from 1.8 all the way to the right side, so it's positive infinity. So that's from the graph. But to figure out exactly what this value is it negative 1.8, 1.9, or 1.7 or something, then we'll have to use we'll have to find the second derivative and set it equal to 0. These are the point right here, and this point and this point. These are called points of inflection. So let's rewrite this as 4 times 1 over x squared, and then plus 10. And again, this is the same as 10 to the first. And so this becomes 4 times x squared plus 10 to the negative 1. And then now we can find the first derivative and use the chain rule. So this would be 4. And then the chain rule says that put the exponent in front of the base. So the base here is x squared plus 10. So it would be negative 4 and then x squared plus 10. And then subtract 1 from the exponent. So we get negative 2. And then times the derivative of the base. The base with the chain rule, normally we call it u. So the derivative right here, this is 2x. Derivative of x squared is 2x. Derivative of the constant 10 is 0. And so altogether we have 4 times negative 1 is negative 4 times 2x is negative 8x. And then so we have negative 8x. Let's write it like this. And then times this. And then this will be negative 8x. And then times, and this is negative exponent. And then we can just go ahead and leave it like that. And then now we need the second derivative. And this is a product, so we have to use the product rule. So it would be negative 8x times the derivative of the second factor, and then plus the second factor times the derivative of the first factor. This part is simple, so the derivative of negative 8x is just 8, negative 8. And then the derivative of this part right here is going to be negative 2 in front of the base, and then subtract 1. So put negative 2 in front of the x squared plus 10, and then subtract 1 from the exponent, and then multiply by the derivative of the base, which is 2x. Now let's simplify things a little bit. One more time, the derivative of this, we use the chain rule. And so the chain rule says call this u, which I call the base. And so put negative 2 in front of the base, and then subtract 1 from the negative 2, and we get negative 3. And then multiply by the derivative of the base of the x squared plus 10, which is 2x. So that's all we had. And so now we have negative 8x times negative 2, and then times 2, which is 32. So we have 32x squared and now let's rewrite this a little bit. Negative 8x times negative 2 times 2x, that will be 32 x squared, and then this is x squared plus 10 to the negative 3, and so let's rewrite this using positive exponent. So we'll move it to the denominator, and so it becomes 32x squared divided by x squared plus 10 to the third. And same thing over here. Let's make this, turn this into a positive exponent by moving it to the bottom. So we get negative 8 dividing by x squared plus 10 to the second. And since we have this quotient plus this quotient, then we can do cross multiplication. So it would be 32x squared times x squared plus 10 to the second, and then negative 8 times x squared plus 10 to the third, and then dividing by the product of the two denominators. So cross multiply and then divide by the product of these two. This is x squared plus 10 to the third times x squared plus 10 to the second, and so add the two exponents and we get x squared plus the x squared plus 10 to the fifth. And then this part right here, this is 8 times x squared plus 10 to the third. Let's rewrite it as 8 x squared plus 10 to the second, x squared plus 10 to the first. Reason we're doing this so that we can factor out the x squared plus 10 to the second, since we have an x squared plus 10 to the second right here. And now if we look at this part and then compare with this part, the common factor is x squared plus 10 to the second. So let's move it out in front, and then what's left is 32x squared, and then minus 8 times x squared plus 10. So x squared plus 10 to the second is the common factor. And so move it to the front. And this becomes 32x squared minus 8x squared, and then 8 times 10 is 80. 32x squared minus 8x squared is 24x squared, and then minus 80. And now to find the points of inflection right here, we set the second derivative equal to 0. And so we have this part right here equal to 0. And then notice the following: the bottom will never be 0, because x squared plus 10 will always be greater than 0. And so the only part that can be 0 is this. And which means that this is equal to 0, or this is equal to 0. This is x squared plus 10. And so this part right here, it will always be greater than 0. It will never be 0. And so the only thing that could be 0 is this. So we get 24x squared. Now add 80 to both sides. We get 80. And so x squared is 80 over 24. And if we reduce this, divide the top by 8, divide the bottom by 8, then we get 10 over 3. And now take the square root of both sides, and we get x equal to the square root of 10 over 3. Which is 1.82574185. And that's what we saw right here. This right here is the square root of 10 over 3, or 1.8257 negative, and then positive over here. And so that tells us that the graph, the function, the original function right here, concave upward on the interval from the left side to negative square root of 10 over 3. Left side, which is negative infinity, and then to negative and then it also concaves upward on the, and then let's go to the middle, and then downward on the interval from negative square root of 10 over 3 to the square root of 10 over 3. And then the last part, it concaves upward on the interval from 10 over square root of 10 over 3 to the right side, which is positive infinity. And once again, we get for this interval, graph concaves up, and so we pick any number in here. Let's say we pick negative 3. And then use the second, evaluate the second derivative at negative 3, meaning second derivative here, put negative 3 here, negative 3 here, and negative 3 here. Then we'll end up with positive 0.01, which is greater than 0, because the function concaves up on this interval, so that's why the second derivative is positive. And if we picked any number from this interval, let's say we pick 0, and then evaluate the second derivative at 0, and then we get a negative number, which is less than 0. And same thing here, let's say we pick a 3 from this interval, and then evaluate the second derivative at 3, positive 3, then we'll get a positive number like this. So that's what the second derivative test is.